Part B of the TVM chapter deals strictly with annuities. We'll still be using the TVM keys on the calculator, but now the payment register will not be zero. An annuity is defined as a series of equal payments, inflows or outflows, that occur at regular intervals for a finite period of time. An ordinary annuity is one where the first payment occurs at the end of the period. This is the default in your calculator and in Excel. An annuity due is one in which the first payment occurs at the beginning of each period. A variation of an annuity is the perpetuity, equal payments, equal intervals, but the period is infinite. Preferred stock, which we cover in Chapter 9, is a perpetuity. These timelines show the difference between an ordinary annuity and an annuity due. Same number of payments, but with an annuity due, they all occur one period sooner. This drives a technique to solve for the value of an annuity due that we'll look at on upcoming slides. First, let's get valuing a perpetuity out of the way. Simple formula: payment divided by required return. The formulas for the future value and present value of an ordinary annuity are shown on the slide. I have no expectations that you'll actually use these formulas, but I'm showing them for a reason. These are the future value and present value formulas for annuities due. Note the difference between the two pairs of formulas. The value of an annuity due, future value or present value, equals the value of a comparable ordinary annuity times 1 plus the interest rate. This provides us with a solution technique. The payment key on the calculator is used for that equal payment. The sign convention is extremely important. If you want to use the settings in your calculator for an annuity due, you switch it to begin. The default is end. Look at your calculator display. The upper right-hand corner is blank. Your calculator is set to end. To change to begin, press second and BGN. It's above the payment key. BGN and end is a toggle. To change to begin, press second and set, and you'll see BGN appear in the upper right-hand corner. Press second and set again, and BGN disappears, and you're back to end. Press second and quit to set the displayed choice. The calculator stays set to begin unless you change it back. This is great if you're continually dealing with annuities due. Not so good on a one-time basis, as you may forget to reset it to end. We'll be using the TVM keys, but with annuities, the payment key is not zero anymore. The sign convention is very important with payment. A wrong sign on present value or future value when payment is zero only results in the wrong sign on the other one. A wrong sign on payment can change the answer completely, not just the sign. In Excel, we would still use the functions corresponding to the 5 TVM keys with one alteration. Type is 0 by default, which equates to end, and it can be left blank in Excel. To specify begin, type must be set to 1. We usually think of periods on the timeline as years, but they don't have to be. Period could mean months, weeks, days, whatever time frame is specified. It's important to remember that the interest rate, time period, and payment period must match. Annual periods, years, means the interest rate must be an annual rate, and any payment is an annual payment. Monthly periods means N is the number of months. The interest rate must be a monthly rate, and the payment is a monthly payment. It's sort of a least common denominator thing. And do not forget the sign convention. It is critical when you're using payment. These two problems look the same with one major difference. In the problem on the left, payment is a positive $20, implying that you will receive $20 every year for 5 years. Payment in the problem on the right is negative, implying that you'll add $20 to the account every year. A big difference. Everything else about the two problems is the same except the sign of payment. Note that the answers don't just differ by sign. They're totally different. First, let's look at an example of solving for the future value of an ordinary annuity. 3-year annuity, 4% annual rate, you deposit $100 each year. Payment is negative since you're depositing the $100. The future value will be positive. This problem looks the same, but is slightly different. 3-year ordinary annuity, 4% annual rate. The question is, how much do you need to deposit negative now to withdraw a positive $100 each year? N is 3, IY is 4, payment is $100, future value is 0, compute present value. FV is 0 as you want to draw the account down to 0 at the end of 3 years. On the next 2 slides, we'll look at the same 2 examples we just covered for ordinary annuities, but analyze them as annuities due. First, look at the equation and solution in the red box. We're using the fact that an annuity due is equal to an ordinary annuity times 1 plus the discount rate. Below, you can see where we changed the calculator setting to begin. Note that in Excel, the type is set to 1 to indicate an annuity due. Solving for the present value of an annuity due is handled in the same manner. Either the ordinary annuity times 1 plus the discount rate, or set the calculator to begin and set the type to 1. Here's a real-world example of the power of compounding. A 20-year-old student wants to save $5 a day for her retirement. So every day she puts $5 in a drawer. At the end of the year, she invests the accumulated savings, $1,825, in a brokerage account with an expected annual return of 8%. How much money will she have when she's 65 years old? This is a future value of an ordinary annuity problem. N is 45 years. IY is 8. Present value is 0. There's no mention of her having money in the account to start with. The payment is a minus $1,825. Compute future value. At the end of 45 years, she'll have $705,373. If a 40-year-old investor begins saving today and sticks to the plan, he or she will have $133,418 at 65. This is almost $600,000 less than starting at age 20. The moral, start saving early. It pays off. Suppose the 40-year-old wants to catch up with the 20-year-old. How much must he deposit each year to end with the same amount as the 20-year-old? N is 25, IY is 8, present value 0, future value $705,373. Compute payment, almost $10,000. So instead of saving $1,825 a year, he needs to save about $10,000. This ends our coverage of annuities. In the third part of Chapter 5, Part C, we finish our introduction to time value of money.